Arpita. So our next speaker is Mr. Vamsi Krishna. He will be giving overview on asphalting mix and mix design practice in India. Mr. Vamsi is currently pursuing PhD at IIT Bombay under the supervision of Professor Dharmit Singh, and essentially his particularly research interest is on rutting performance of asphalt mixture. So he's trying to study the high temperature performance parameters. So prior to joining IIT Bombay, he actually completed his masters from NIT Bhopal. So before giving any further delay, I would like to hand over the floor to Mr. Vamsi. Over to you, Vamsi.
Thank you very much, Dr. Praveen. Like, you have given very nice introduction. So without any further delay, so we'll go with our part 3 presentation. So which is on aggregate gradations and bituminous mix design. So which is more focusing on in India. So different type of in this presentation we'll be going to discuss about aggregate gradation, what different type of aggregate gradations we are using, and the bituminous mix designs we do in India. And so these are the some relevant guidelines for the bituminous mixes we followed in India. So this is the MOTH, so which is already discussed by Dr. Bharat at the initial presentation. And for the dense graded mixes, we have IRC 111209, and for the SMA and GGRM, we have two different codal provisions. So what type of aggregates we use in the bituminous mixes, like what different types of bituminous mixes and aggregates and fillers we use. So these are the different aggregates we use in the bituminous mixes. So basalt, granite and limestone, sandstone, quartz, slag, etc. And the fillers are like rock dust, hydrated lime, and cement and fly ash. So these are the different aggregates and fillers we use, and this is how we like aggregate production of aggregates in the quarry and all. And so mostly like we use crushed stone or crushed gravel, and we use different type of crushers to produce these different sizes of aggregates, like based on like jaw crusher, vertical shaft impactor, and horizontal shaft impactor, and cone crushers to produce different type of aggregates. And then so these are the bitumen types. Just it's a slide like already discussed by Ms. Arpita previously. So just to give the slide of the different type of binders. And with this, we move to the type of bituminous mixes in India we have. So these are basically like majorly we have mix types as two different types, dense graded mixes, and another one is gap graded mixes. And in the dense graded mixes, we have two different categories. One is dense bituminous macadam, which is popularly known as DBM, and another is bituminous concrete, which is known as BC. In dense bituminous macadam, we have two different gradations again, based on the nominal aggregate size. DBM1, which is having nominal aggregate size of 37.5, and DBM2, which is having 26.5 mm. And similarly for BC, we have BC1 and BC2 having the 19 mm and 13.2 mm nominal aggregate size respectively. And when it comes to gap graded, again we have two different gradations: stone mastic asphalt and gap graded rubberized mixes. So SMA1, which is having 13.2 nominal aggregate size, and SMA2, which is having 19 mm nominal aggregate size. And in gap graded, we have only one type of aggregate gradation. So the NMSA is a nominal aggregate size, which is the largest sieve which retain the aggregate proportion, first largest sieve which retain the aggregate proportion. So then we move towards the dense graded mixes. We discuss like what type of gradations and how the upper limitations and all in this mix design, and their limiting values and everything we are going to discuss in this dense graded mixes. So firstly we start with the dense bituminous macadam. So we have two different gradations. This is the first sieve which retain the aggregates, so which is a nominal aggregate size DBM1 and DBM2, and these are the upper and lower limits for the aggregate gradations. So you can see the in fine proportion, like both gradations are overlapping. but however the major change is in the coarser proportion. And so we have the minimum binder content by percentage of total mix. For DBM1 we have 4%, and for DBM2 we have 4.5%. So which is corresponding to the based on aggregate specific gravity, so being equivalent to 2.7. If there is any change in the aggregate specific gravity, this minimum binder content will also change. And so this majorly dense bituminous macadam is used in base or binder cores. So similarly, we have bituminous concrete, which is more finer gradation as compared to the DBM. So we have again two gradations, 19 mm nominal aggregate and 13.2 nominal aggregate size. So these are the two different gradations. This is one BC2, which is finer, and BC1, which is a bit coarser side. And this you can see the BC2 is more close to the maximum density line, so which is more denser gradation. And similarly, we have a minimum binder content for these two, 5.2 and 5.4, and this is more popularly used as surface or wearing cores. And these are the aggregate properties for the dense graded bituminous mixes. Like we have like aggregate properties will be checked in, like these are the properties will check before going to use in the bituminous mixes. For the coarser proportion, we have like cleanliness, particle shape, strength, durability, polishing, absorption, and these are the tests we do on the aggregate. Different type of tests for the evaluate these properties, and these are the limiting values, like to approve the aggregates used in the mix. For the cleanliness, this is less than 5%, and likewise combined flakiness aggregate should be less than 35%. And here for the strength we have two different values, because DBM is more mostly used in the lower layers, so we have like 35 and 27. But for the BC, mostly we use in the surface or wearing cores, we have some strict requirement as compared to the DBM and BC. Other than this, all requirements are like mostly same for the both the gradations. For the fine gradations, we have clay content property check clay content. So we check the clay content proportion using sand equivalent method and the plasticity index. So based on that, these are the limiting values for the fine aggregate properties for the dense graded mixes. So then after doing the aggregate property, checking the aggregate properties and all, so what type of mixed design we do, bituminous mixed design we do in India? So we follow Marshall mixed design method. So it starts with the material selection, as I discussed earlier, like it should satisfy all the aggregate properties. Then the binder we select, and then the aggregate gradation we select, and then we mix with the binder with the different proportions. Then we use Marshall compactor to compact the sample, and we determine the maximum theoretical specific gravity and the well density of the samples. Based on that, we determine the optimum bitumen content corresponding to the 4% design air void. And after determining this, we evaluate the moisture sensitivity using tensile strength ratio parameter. So if it is greater than 80%, we approve the further process. And along with this moisture sensitivity, we have other requirement which is having like Marshall stability and flow. So for the dense graded bituminous mixes, we use 75 blows for the compaction, both sides of the samples, each face of the specimen. So we use sample size of 4 inch, which is 101.6 mm diameter, and 63.5 mm height, which is 2.5 inch height. Basically standard Marshall method when the aggregate nominal aggregate size is up to 26.5 mm. If the aggregate size is more than 26.5 mm, then we go for the modified Marshall method, which is having the 6 inch diameter and the 3.75 inch height as per ASTM D5581. So here we have to note that here we use in standard Marshall we use only 75 blows, but to like same compaction to ensure the equivalent compaction, the blows is 1.5 times than that of the standard Marshall method. So if it is 75 blows, which may be approximately equivalent to 115 blows for the modified Marshall method. Then these are the other volumetric requirement, Marshall volumetric requirements. Then this is the air void selection, then the VMA criteria and VFB and other Marshall and stability. So this is how we measure all the capture the volumetric parameters. Then this is the important performance test we do in the mixed design. So for moisture damage test. So this is the typical sample dimensions based on the nominal aggregate size and the air void content we maintain for the sample preparation, and we condition at 25 test temperature is 25 degree, and degree of saturation we do at 70 to 80%, and this is the conditioning time. Like here you can see there are like conditioned specimens and dry specimens. So this is the dry specimens we test directly at 25 degrees centigrade, but the conditioned specimens we condition at 60 degree for 24 hours, and then we test the specimens. If the then we measure the TSR, like we by using this equation, ITS conditioned and ITS nothing but indirect tensile strength and condition. If this tensile strength ratio is greater than 80%, then we approve the thing. Then these are the volumetric and the strength requirements for the dense graded bituminous mixes. So this is the, like you can see, minimum stability based on the unmodified binder or modified binder, and depending upon the climates and all, and the Marshall flow requirements similarly. And we have the Marshall coefficient also, like which is the ratio of stability or like stability by flow. So this is the requirement. And volume VFB, volume filled with the bitumen, and more importantly, like also filler to binder ratio, which is the range from 0.6 to 1.2, and the coating of aggregates, and this is the tensile strength ratio. So you can see, like now you can see the summary of the bituminous mix design. This is the 3 different steps, and we check and we have to approve the mix design. The check one, we say take determination of OBC at 4%, optimum bitumen content at 4%. Then the check 2 like volumetrics and stability and flow, and the next check number 3 is tensile strength ratio. If it is greater than 80%, all 3 criteria are satisfied, then we approve the mix design or for the production of JMF, job mix formula. So this is all about the like how the gradation type of gradations and how the mix design and how the aggregate properties we know. Now we move towards the gap graded mixes. In the gap graded mixes we start with the stone mastic asphalt, popularly known as SMA in India. So these are the 2 different gradations we have gap graded. One is 19 and 13.2 nominal aggregate size, and this is the typical gradation range for both the gradations, and this is the minimum binder content we use in the mix design. And other than this gradation, we also use some fibers in the mix, which is having minimum 0.3% by weight of total mix, and this is like used in because of the highly like heavy traffic areas, and which is mostly used in wearing our binder courses. Then these are the aggregate properties. So you can see I have aggregate properties, same properties we check, but here I have highlighted 2 properties here in the dense graded as compared to these are different from the dense graded. So you can see there it is 5%, but here it is 2%, and the abrasion value or impact value, you can see this is or like abrasion value or impact value, it has to satisfy. So more strict stringent requirement you can say for the coarse aggregate property, because in the most majority, like mostly approximately 70% is the coarse aggregate, so we have more strict requirement for the strength criteria. So and then one thing we have to remember, like in the polishing value, this is only applicable for the nominal aggregate size of 13.2 gradation, because this 19 mm nominal aggregate size, so we use mostly as a intermediate or binder course. So this is how the same Marshall mix design method we follow for the SMA, but the blows is going to be changed, which is 50 blows on each face of the specimen, and the optimum bitumen content is determined corresponding to 4% air void, and this is the standard sample size, and this is the typical sample looks like stone mastic asphalt, and this is the volumetric criteria. Then this is the volumetric and strength requirement. you can say like 50 blows, and this is the minimum voids in mineral aggregate requirement, and the voids in the coarse aggregate of the mix must be less than the voids in the coarse aggregate of dry condition, and Chandra ratio is minimum 85%. And here you can see that there is no Marshall stability requirement, but however, like in other countries have some stability requirement of maybe 6 kilonewton. Then we have other gap graded mix is gap graded rubberized mix. This is the typical gradation, and this is the typical limits of the gradation. And here we use the crumb rubber, we use in the gap graded rubberized mix with the bitumen, and minimum percentage should be used in 20% by weight of the bander, and its viscosity, minimum viscosity must be 1500 centipoise at 177 degree, and this is the range of the specific gravity. And one thing we need to keep in mind that what type of base binder we need to use to mix with the crumb rubber. If the traffic is greater than 30 MSA and the temperature is greater than 30 degrees Celsius, we use VG30. Otherwise, we go for the VG10 as a base binder. So this is like popularly used in the like gap graded bitumen rubberized mix in like countries like USA and Sweden and South Africa and countries. And also in India also we more popularly like some stretches were constructed in Maharashtra, West Bengal and Tamil Nadu. So more popularly used in the surface or wearing course. So this is the same aggregate properties requirement similar to the stone mastic asphalt. This is the typical mix design. Here again we use 75 blows, but the optimum binder content we selected 5% design air voids, and this is how the typical gap graded rubberized mix sample looks like. And this is how we select the 5% air void. We select the optimum binder content. Then this is the requirement. Here like IRC SP107 has provided some minimum stability criteria. However, grab-bladed mixes SMA do not have any other requirement. And you can see the higher minimum voids in mineral aggregate BMA requirement here. And this is the tensile strength ratio requirement. And now we see like a summary of the mixes. For the all mixes we have discussed the dense graded and the gap graded with the different size, nominal aggregate sizes, and you can see the minimum VMA. This VMA is corresponding to the 4% design air void, and however like for GGRM, which is corresponding to the 5% design air void. And you can see the bitumen content is increasing as decreasing with the nominal aggregate size, and the VMA also increasing. And so this is all about the like different type of mixes we use in India with the like dense and the surface and the base or binder course we use in India, and this is the requirement we discuss on the mix design and all. But we in IIT Bombay, like we are working on some advancement in bituminous mixes in India. So first thing which comes like the mix design, like Superpave mix design method we are working on. This is used as a major change is the Superpave Gyratory compactor, so which simulates the more field densification type of condition. This is the Superpave Gyratory compactor, and this is the sample after compaction using the Superpave Gyratory compactor. This is the principal used in the compaction. We apply the ramp pressure of 600 kilopascal plus or minus 18 kilopascal, so with the 30 gyrations per minute. And this is the angle we give in the compaction. And this is there is in Marshall compactor we apply impact load. Here we apply the pneumatic type of loading, and needing action we give. And this is the typical compaction effort for the based on the different traffic 20-year design. And this is all about the Superpave mix design. And also like in India we are doing mix design based on volumetric based mix design, and but in India like we has increased traffic volume and heavy axle loads and all. So we are also working on the rutting performance of the asphalt mixer, as rutting is the major concern, and we are working on like rutting performance using Hamburg wheel tracking test and all. So this is the test conditions, like sample dimensions using 150 and 65, and the wheel load we apply here, and the air void content maintained, and test temperatures is approximately majority of the India is having this type of temperatures. and this is the our Hamburg wheel tracking test we use, and this is the sample preparation you can see, and this is the thing LVDT to measure the deformations, and this is the wheel which moves to and fro. And you can say, like, let's say two different mixes having similar volumetrics, which may give the two different rutting performance. You can see mix B is having very good resistance as compared to mix A. So with this, Professor Singh, would you like to add something?
Yeah, Vamsi, I think thank you very much. I think you have given very nice overview. So I just would like to tell all the audience this Superpave mix design, it is not very new in India, though we have not implemented it largely, but a lot of work is going on, and we hope, I think we may have some trial sections on design of bituminous mixes using Superpave. And also many agencies, we have seen that some of the contractors and some agencies are quite interested to do the rutting evaluation. Basically, we have seen a lot of rutting on many highways in a couple of months, and a lot of interest is getting generated to do the rutting evaluation of SMA or like BC and all. So we are hoping that in coming years or so, people will get a little bit kind of, like a lot of understanding that, yes, I think we need to go toward the balanced mix design or performance-based mix design, so that we can really, like resolve that kind of issues. Yeah.
Thank you.
Yeah.
Thank you. So with this, I think I conclude my part of presentation. So I hand over to Dr. Praveen.
Yes, thank you, Vamsi, for such a nice presentation. So you have covered a wide spectrum of mix type, right from this dense graded mix to the gap graded, currently practiced in India. So we have nicely covered various aspects, such as like aggregate gradation, different volumetric requirements, etc., for different mixes types. So you have also given like little bit glimpse on future plans for shifting from master mix method to Superpave mix design, which was nicely covered by you. So there is an announcement. So we will take about 10-minute short break, and then again we will resume the session. Meanwhile, enjoy snacks, drinks wherever you are, and get refreshed. And I hope that you all will again come back, and then I mean, don't go away. Keep connected, and we'll start after 10 minutes.
Yeah, Praveen, I just would like to add here to all the participants. We have a very interesting session coming up after 5-10 minutes break by Dr. Bharat Rajan about the pavement design principles, like different kind of cross section that we use in India, and what kind of basis that we have. And then we have another very interesting presentation by Burhan, who is going to talk about what is technological advancement. A lot of new technologies are coming up. In fact, we are calling it new, but a lot of new development is happening in India also. A lot of technology is getting implemented. So he is going to give the overview on that. And Parveen has mentioned, we are going to answer all the questions as far as possible. Either you are dropping it on your YouTube or like in the chat box here. We may not be able to answer instantly. So please don't mind it. Don't take it, like that we are not responding or we are ignoring. It is not like that. We are going to answer the questions later on, so that we can discuss like everything in one go. So whoever is there on the YouTube, and thank you very much for posting a lot of questions. Yeah. We'll try to wrap it up. Dr. Professor Sarif, would you like to add anything here?
Yes, of course. I would like to first of all thank you very much, and your colleagues as well. The first part of this webinar is actually very informative and knowledgeable. I personally learned a lot about the practices in India, and you guys have your own specs. This is the first time I've seen you know, a spec for the crumb rubber modified asphalt. It's not Superpave. It's not, you know, based on penetration grading. I think it's made up by your scientists and, you know, professors to have, you know, very specific, you know, characterization method for the crumb rubber modified asphalt. This is very interesting, and I would like to discuss this more with you, maybe, you know, after we finish our webinar, you know, later, not today. I know that it's going to be late in India, but yes, it's really very nice, you know, presentation so far, and I think all of us are very excited to see the other part of this nice webinar.
Thank you, Professor Sarif. And I would also request you later, because in India, a lot of, you know, like we have been conducting a lot of webinars, and we see a lot of interest among highway engineers, researchers, you know, like to understand what are the practices in the Middle East. And I attended your one of the presentation where you gave very interesting presentation about what are the practices that Middle East is using for the bituminous pavement and all. Maybe in the future we may think about that as a part of our collaboration. So I think today we have more than, I think, 1,000 participants, those who are registered. But some of them on the YouTube, some of them they are here. So thank you very much for all of you for joining us from different part of the world, and we welcome all of you. And we apologize if you have some network issues, some, you know, like lag was there, or somehow we could not respond to your queries or something. But we'll try our best. We'll improve with time, and hopefully we'll come up with more kind of such interesting webinar for all of you in the future.